Today I want to test you a math problem. The name of this problem called General Counting Soldiers. Can you help the general with your knowledge of mathematics? Let's see what their general's challenge is first. A long time ago, a general led his army to the front. After a fierce battle, when they returned to their headquarters, the general wanted to review his troops and needed to know how many soldiers survive. In the beginning, the general ordered every 10 men to be in a row. In the end, he found that only one man was needed to fill the row. Just like the icons on the screen, this represents the last row of the line, and the blue soldiers represent the empty one. The general thought this was unlucky. So he arranged soldiers in a row of 9, but again the last row needed one man to fulfill. Then he arranged soldiers in a row of 8, but again, the last row needed one man to fulfill. Then he arranged soldiers in a row of 7, but again, the last row needed one man to fulfill. Then he arranged soldiers in a row of 6, but again, the last row needed one man to fulfill. Then he arranged soldiers in a row of 5, but again, the last row needed one man to fulfill. Then he arranged soldiers in a row of 4, but again, the last row needed one man to fulfill. Then he arranged soldiers in a row of 3, but again, the last row needed one man to fulfill. Then he arranged soldiers in a row of 2, but again, the last row needed one man to fulfill. True, the general was unlucky, but it did happen. According to the above, can you know here at least how many soldiers the general has in his army? That is all a mathematical problem. Our first step is to express the above question in a precise way, which will help us clarify our thinking. Let's set the number of soldiers in the army to be X. In this case, we can use the concept of the remainder in mathematics. Like the last row of soldiers in a row that is not full, these extra numbers that are not divisible are the remainder. And then, we need to use the remainder notation to represent each of the permutations of the soldiers, and that's the notation mod. For example, let's say that x mod 10 is equal to 9 for the first q. That means x divided by 10 has a remainder of 9. And so on. We can get other formulas on the screen. When you look at these formulas, your reaction must be, what are these? You don't see any pattern. I can't do it directly from these formulas or find any patterns. That is a false model, but it's the most direct way to represent it, and most people do it. Now, let me show you a better way. We know that every time the general lines up a soldier, one more person fills the line. In other words, the total number of troops need one more person to fill the line, mathematically speaking, to make it no remainder. It's straightforward. For example, we could say x plus 1 mod 10 for the first permutation. That means x plus 1 is an integer multiple of 10. And so on. We can come up with other formulas on the screen. Have you noticed a pattern? 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 Have you noticed a pattern The minimum of x plus 1 is the least common multiple of the numbers from 2 to 10, so we can go further and figure out the minimum of x. We succeeded in turning the problem into calculating the least common multiple of a number from 2 to 10. But how do you calculate it? It's also a challenge. Before calculating the least common multiple from 2 to 10, to give you a better understanding of how to calculate, I will introduce you to the concepts of prime and composite numbers. A prime number is a natural number higher than 1, that cannot be formed by multiplying two smaller natural numbers. For example, the numbers 2, 3, 5, 7 are prime numbers. On the contrary, a natural number greater than 1 that is not prime is called a composite number. As shown on the screen, a composite number is equal to two or more primes multiplied, which act as factors of a composite number. And a prime number is the factor of itself. It's not hard to understand that for an amount to be the least common multiple of a number from 2 to 10, the prime factor of the amount must contain all the elements above, but the number of factors must be the least. So we take the combinations of these prime factors, and we don't double count them, and we multiply them together to get the least common multiple of them. Okay, now look at the screen and let's start this number finding game. First of all, to be the least common multiple of 2, its prime factor, of course, contains 2, so let's write down the number 2. The same is true for number 3. And then number 4, it has 2 prime factors, both of which are number 2. And here's the point, because we've written down a prime factor of 2, so we don't need to use the first prime number, 2, let's do it in red. Since we only have one prime number, 2, we need to write down the second prime number, 2. Once again, prime number 5 is not included, so let's write it down. For number 6, both of its factors have appeared, so we'll label it red. Well, the number 7, which is itself a prime number, hasn't been counted yet so that we can write it down. For the number 8, it's 3 prime numbers 2 times each other, and obviously we've found 2 prime numbers 2 in the formula, so the first 2 prime numbers 2 can't be counted twice, so we'll make it red, and then we'll just write down the last prime number 2. For prime number 9, the first factor has already appeared once, so it can't double counted, so it's labeled red. And number 9 to be formed by 2 prime number 3, so the formula must also contain 2, then we write another 1 into the equation. Both primes of the number 10 have already appeared, and now the product of the factors written down must be multiples of 10, so both of its primes are labeled red. You can multiply the yellow numbers, and you get the least common multiple, which is equal to 2520. That means the general's army has at least 2,519 men. Explain it again. We know that if we multiply all the numbers, that is to say, multiply all the prime factors, we can figure out the common multiple of all the numbers, but it's not the least common multiple. As we did above, all we need to do is remove the prime factors from the repeated calculations, and these are the numbers that are marked red. And then you multiply the yellow numbers. So that's the basic idea of figuring out the least common multiple. That is also consistent with the algorithm of finding the least common multiple of the first 2 numbers, then using that number to find the least common multiple between it and the third number, and so on, and finally figuring out the least common multiple of all the numbers. You might think that's a tricky way to do it. It doesn't matter. This algorithm is introduced here mainly for the audience to understand the principle of this algorithm clearly. So I'm going to continue with this, and I'm going to show you another way to do this which is more intuitive. Now let me show you the second way to calculate the least common multiple. The first step is to list all the numbers, and then find the number that has the same prime factor. For example, numbers 2, 4, 6, 8 have the common factor 2. We divide these numbers by the same factor 2. And then, we keep the other amounts the same, and we replace them with the quotient. And then finally we're going to write our new sequence in the second row. Step 2, again, find the number in the second sequence that has a common factor. For example, 3, 3, 9 have the same factor 3. And then we divide them by the factor 3. And so on. You get a new sequence written in the third row. Step 4, we found that the common factor of numbers 2 and 4 are 2. Using the same algorithm we reach the fourth sequence. The next step is to notice that even though only two of the same numbers have a common factor of 5, and the common factor is themselves, you still have to divide them by the previous method to get a new sequence of numbers. When it came time to do the magic, we discovered that we could get the least common multiple by multiplying the peripheral numbers. Let's test that out. And sure enough, when you multiply it, you get the same answer as you did the first way, which is 2520. How did this happen? The principle has been mentioned before. We can multiply all the factors of all the numbers, and we get their common multiple, but it's not the least common multiple, because some of these factors are double counted. The challenge is to find the common factors between the numbers because they can only be counted once. So what we did up here is that we figured out the common factors of numbers, so we don't have to do double counting. For example, let's look at the next to last sequence. There are two numbers of 5 in the sequence, but by dividing by 5, it becomes just 1. So when you do the least common multiple, there's only one 5 left in the formula. That's where this video ends. Guys, if you like video, be sure to subscribe to my channel. Thanks.